Welcome to the Maharashtra State Board of Technical Education is coming with the lead learning at your doorstep. The name of course is Utilization of Electrical Energy. Unit is Electric Drives and Elevators. Unit outcome is estimate relevant size and rating of electric motor for the specified load cycles. In the today's session, we are going to learn the standard rating of the motor as per IS. We'll see the duty cycles or the load cycles. Also, load equalization. And key takeaway of the today's session is different type of ratings: continuous maximum, short time rating. Also the types of load: continuous loading, short time loading, intermittent loading, continuous operation with short time loads, continuous operation with intermittent loads. Learners may pause the presentation and can note down the concept map in their notebook. Now, the size of motor mainly depends upon the time of operation, that is, for how long the motor is working. So, it can be considered under the following class, that is continuous rating, short time load, intermittent rating, continuous operation with short time loads, and continuous operation with intermittent loads. Among all of these ratings, there is a difference in the on period and off period of the motor. During the on period, there will be increment in the temperature of the motor, and during the off period, motor will be cooled down. So on period and off period make the duty cycle, which is the ratio of on time upon the total time of operation of the motor. Now we will see the load cycle or the duty cycle. It is for the continuous rating. In the graph we can see that motor output or the load is constant for the long duration of time. So motor has to supply a constant and continuous load, isn't it? Therefore the temperature will increase. So it will lead to the excessive temperature rise. Characteristic is shown in which the continuous line indicates the motor output and dotted line shows that continuously the temperature is increasing. Example of such type of load is the pump load. Now the short time rating, which is also known as the short time operation or the short time loading. So the load is present at the regular intervals, that is in between the intervals motor is off. So during the on period, the temperature it will increase from the ambient temperature. During the off period, which is utilized as a cooling period, so motor will be cooled down and again motor temperature will reach to the ambient temperature. Example of this kind of load are lock gears, bridges, weights, etc. Diagram is very helpful here. Long time rating, also known as the intermittent rating, it is similar to the short time, but only difference is that on load time and off load time is same, and off load interval is not sufficient to cool down the motor to the ambient temperature. As a result of it, there is a continuous increase in the temperature of the motor. So example of this type of load are cranes, lifts, rolling wheels, etc. The continuous operation with short time rating or loading, in this case interval between the two load is not off load period, but motor run on no load condition. Therefore, if we talk of the cooling of the motor, the cooling is done during the no load interval. Example is a Ward-Leonard method whose generator is intermittently loaded. The temperature rise and cooling can be seen by the dotted line in the diagram. Continuous operation with long time rating or operation or loading, or it is also known as a intermittent. So in continuous operation with intermittent load, it is just similar to the intermittent loads, except that the off period is totally replaced by the no load intervals. So during no load period there is a completely motor is off, but at no load there is a no load losses. So the temperature rise curve is shown in the figure. Till now we have learned the different type of rating, but now we will see the concept of the load equalization. There are some kind of load which are fluctuating in the nature. The fluctuation is very widely within the short interval of time, that is from very high to the low. It goes on. So when the heavy loads are suddenly applied on the motor, it will draw the heavy current. As a result of it, it will produce the large voltage drop, and in the line and in armature conductor also. So we have to select the cable from the point of view, and we have to select the bigger size of cable as well. So these are the difficulties which are happening. So in order to avoid, the load fluctuations are reduced or smoothened out. So how it is smoothened out, this process is known as a load equalization, and this is done by a device which is known as a flywheel. So flywheel is mounted on the motor shaft itself. Unnecessary condition is that motor rotation should not reverse. So when the sudden load is applied on the motor, its speed will decrease and also the output decrease. During this period, the flywheel release its kinetic energy. Therefore, total output is the addition of the power taken from the supply plus output of the flywheel. On the other hand, when the load on the motor is decreases, its speed increases. Therefore, the output of motor also increases. During this period, flywheel absorbs the excessive energy given by the motor, and the constant output is given to the load. This complete process is known as load equalization. Whenever load fluctuation is there, so in order to increase the moment of inertia of motor, flywheel is used. During the period when the load is small, the flywheel accelerates and thus store the kinetic energy, and thus the demand on the supply side remains constant. It means it will not decrease. But when the load increases during the peak period, the flywheel gives a part of its kinetic energy and thus help in decreasing the demand on the supply side. So this practice, it is done by the flywheel. In the given graph, we can see that load torque is adjusted by the motor torque plus the flywheel torque, and also the speed fluctuations are minimized, or the speed is totally smoothened out with the help of the flywheel. So this type of situation comes under the steel bar billet or the rolling mill operation or the colliery winders and the planers, where the heavy jobs has to be accelerated but for a very small duration. This is a solved numerical problem in order to develop a proper understanding for the motor rating. That following motor is subjected under this duty cycle: 100 HP for the 10 minutes, no load for the 5 minute duration, 50 HP for the 8 minutes, and again no load for the 4 minutes. So the duty cycle is repeated indefinitely. We have to suggest the rating of the motor. So either it should be 100 HP or more than 50 HP. What should be the exactly one? So first of all, we will see that the total operation it is of the 27 minutes. Student may pause the presentation and can draw this duty cycle diagram. We have applied the RMS method in order to calculate the HP of the motor. So there are total period is distributed among the 4 period T1, T2, T3, T4. T2 and T4 are the no load periods. So the calculation is done and the result is the 66.67 HP. So it was subjected to the 100 and the 50 HP. So concluding result is that it is the 70 HP is adequate for this kind of duty cycle. Students are supposed to practice such kind of numerical mode in order to develop a better understanding. The learner are supposed to note down this question and solve in the notebook. Cross-check the answer. In the same manner, questions are to be noted down in the notebook and answers are to be cross-checked later. Note down these questions also. Cross-check your answers. Practice such type of questions in order to better understanding. Today we have learned the various ratings of the motor and also the various operating condition, and also we have learned what the load equalization is. The students can go through the following reference books and also practice the more numerical from the books for the better understanding of the subject. Thank you very much.